is just negative 1 squared. Negative 1 squared is a positive 1. So it's 15 plus 1, which is just 16. Now we take the square root of both sides, and we're going to have x minus 1 equals plus or minus the square root of 16. Let's add 1 to both sides. And we're going to have x equals 1 plus or minus, square root of 16 is actually 4. So our x values are either going to be x equals 5 and x will equal 1 minus 4, which is negative 3. What I'm more concerned about completing the square right now is this right here. This x minus 1 squared. All right, but we're going to use that later on. The beginning of this whole section here is we're going to talk about quadratics. And a quadratic can just take the form ax squared plus bx plus c. In other words, I'm looking out for what's the highest power of x. My highest power of x is x squared. It is a quadratic function. With all quadratic functions, if you graph a quadratic function, you're going to get a U shape called the parabola. Or if you want to pronounce it wrong, you can call it a parabola. Kind of looks like parabola, but it's parabola. The cool thing about standard form, you can actually get a whole bunch of information from the standard form of a quadratic formula, even though it doesn't quite look like it, because we will talk about vertex form, and we also have a factor form, but you can get a ton of information from just this. In fact, we can get, and we will in just a second, get a pretty accurate graph of what it looks like just by knowing these values. It starts off with our A value. If your A value is positive, your graph is going to open up every single time. So if it's positive, it's going to open upwards. So it's going to look like that. So if your A value is positive, you already should know in your head what a general shape of this graph looks like. It looks like our right side up U. If our leading coefficient A is negative, instead of opening up, it's now going to open down. Which is going to look like that. So just from that A value, you already have a general idea of what this looks like. You already know it's a U. A positive A will make it go up. A negative A value is going to make it go down. So you already have a general idea of what this looks like. The next thing we're going to talk about is our vertex and axis of symmetry, which play off each other. The vertex of the parabola is the highest point if it opens down. So our vertex would be right here. If it opens up, it's going to be your lowest point. Your axis of symmetry is that line. It doesn't go horizontally. It actually goes vertically. Through the vertex, and that's going to be your axis of symmetry. So let's look at this graph right now. Well, just looking at that graph, I know that the A value is positive because it is going up. Just by looking at the graph, I know my A value is positive. But that's not what's key here. What's key here is I want to find my axis of symmetry. Your axis of symmetry is actually a line that runs right smack dab in the middle of your graph. And a lot of times we just call it our AOS. And we call it axis of symmetry because what happens on one side happens on the other side. In fact, it's like a mirror image. So if I look at this point here, I'm looking at that point right there. That point right there is 2 units away from our axis of symmetry, which means the other side is going to have a point that's 2 units to the other side, symmetrical over that line. This can help make graphs quicker because you just have to find like one point over here, know where your axis of symmetry is, flip it across, and you have a pretty accurate graph then. All right, and I also want to note something else here. Let's do purple. This point right here, that is my vertex. And why we deal with axis of symmetry and vertex at the same time? They have the same x value. They have the same x value. Consider this vertical line. If this vertical line was at x equals 3, that would mean this point would be 3 comma something. They have the same exact x value. All right, the formulas for both of these. Our axis of symmetry is a vertical line, so it must be x equals something. X equals a number is a vertical line. Y equals a number is a horizontal line. X equals a number is a vertical line. And it's just going to be x equals negative b over 2a. You need to have that memorized. It makes your life a lot easier. So our axis of symmetry is x equals negative b over 2a. So that axis of symmetry right there is really just x equals negative b over 2a. Well, our vertex is a point. It has an x value and it has a y value. Well, we already know the x value. It is going to be negative b over 2a. Well, if I know an x value, if I said I want to find a point where x equals 2, all you do is you take that 2 and you plug it into your formula. So if my formula was f of x equals ax squared plus bx plus c, I would just take whatever number's here, plug it in there, and the result would be your y value. Because even though it says f of x equals, it really is y equals. So you're just going to take this number and make it your input. So our y value is going to be f of negative b over 2a. In short, find your axis of symmetry. That's your x value of your vertex. Plug it into your equation. Get your y value. You now have your vertex and your axis of symmetry. So we're supposed to find the vertex and axis of symmetry for the following quadratic functions. We're also supposed to say if it has a minimum or maximum. We'll talk about that in just a second. The first thing I want to do is I want to list my a value, b value, and c value. So my a value for this one is negative 2. My b value is 4. My c value is negative 9. Just starting off, your most important point is right here. That is that negative 2. That negative 2 tells you it opens down. Well, the first question is, does it have a minimum or does it have a maximum? Since this goes down forever, it doesn't have a minimum point. It just keeps going down and down and down, so there's no minimum point. The only thing it has is a maximum point, the highest point on this graph. So this graph just has a maximum. So you're going to determine whether it has a minimum or maximum by knowing whether it opens up or down. All right, the next thing I'm supposed to find is the axis of symmetry, and I'm supposed to find the vertex. I'm going to do all that work just below the vertex. In order to find my axis of symmetry and vertex, the first thing I need to find is negative b over 2a. And in this case, my b is 4, so it's going to be negative 4, all over 2 times my a value, which is negative 2. Well, that's negative 4 over negative 4, right? Maybe I'll write that. Negative 4 over negative 4, which just equals a positive 1. Don't forget, negative b over 2a is your key to all of these problems. And you'll see, we'll get to a graph, and I'll tell you, the stuff we're going to do in class right now, there's going to be a problem just like it on the test when we get to it. There can also be problems just like this. Negative b over 2a is my axis of symmetry. So once again, my axis of symmetry is going to be x equals 1. And we get that 1 from here. Once I have my axis of symmetry, I have my x value of my vertex. So my vertex is also going to be 1 comma something. And that something, this y value here, is what happens when I plug this 1 in for this x. So to know negative b over 2a, you need it to get your axis symmetry and your vertex. So our vertex is now going to be f of 1. I'm going to plug that 1 in for my function, which is going to equal negative 2, 1 squared, plus 4x, which is actually 4 times 1, minus 9. Well, that's just going to be negative 2 times 1 squared. 1 squared is 1, so that's just negative 2. Plus 4, minus 9. Well, negative 2 plus 4, that's 2. 2 minus 9 is going to be a negative 7. So this right here is your y value. So we're going to plug this in here, negative 7. So we have a vertex of 1, negative 7. But you couldn't do any of that without knowing negative b over 2a. So you have to know negative b over 2a. Otherwise, there's just a cascade of points gone. All right, next one. We have x squared minus 10. Well, my a value is the one that's right in front of my x squared, which is going to be 1. The b value, I have no x's. My b value goes in front of the x's. Don't make your b equals 1. That's a common mistake. You have 0 x's, so your b value is 0. 0 x's means your b is 0. Our c is negative 10. My a value is a positive 1. Positive means that it opens up, and it means it has a minimum. It drops all the way down here. That's my minimum point. There is no maximum because it goes up forever. Axis symmetry, vertex. You need negative b over 2a. So once again, down here, I'm going to focus on that negative b over 2a. My b is 0, so I have negative 0 over, and really, who cares? Because 0 is my numerator. It should come out to 0. But let's just plug it in. 2 times my a value is 1. That equals 0. So my axis of symmetry is x equals 0, which means my vertex is 0, comma, something. Don't forget, this 0 gives me my axis of symmetry and also gives me my vertex. We're going to plug that 0 into our equation. So we're going to have y equals 0 squared minus 10, which is just going to equal a negative 10. So our vertex is going to be negative 10, or 0, negative 10. Think about how much information is actually there. You know your vertex. You know what direction it opens. You could probably make a pretty nice graph of it already. You just find that point 0, negative 10, make sure your parabola opens up, and you have a pretty good approximation of what this graph looks like. With vertex comes vertex form. And the odd thing is, vertex form gets you your vertex. So if you have f of x equals a times x minus h squared plus k, you immediately know your vertex. Your vertex is going to be h, comma k. That is your vertex, whatever values are in for the h and whatever values are in for your k. Don't forget, if it's inside the parentheses, it's kind of the opposite of what we think it is. Like when we're going left or right, a negative h would actually make it go right. That's why this becomes positive, because a positive h moves it right. So inside the parentheses is opposite what you think. A negative h actually becomes a positive h in our vertex. So if this would be x plus h, your vertex would be negative h, k. All right, so let's rewrite the following quadratic equations in vertex form by completing the square. This is going to be slightly different than what we did for bell work. And what I'm talking about is, let's go back to our bell work really quick. This is where the step's going to get a little different. Here I added negative 2 over 2 squared to both sides. That kept everything balanced. If I add something to one side, I add it to the other side, it stays balanced. Here's the problem. I don't want to add something to this side. I want, at the end of the day, this being y equals something. I don't want to see y plus 16 equals something, something, something. So we only can deal with one side, which means I can no longer add to both sides to keep it balanced. And this is how we're going to do it. So let's just start doing it and then talk about what's happening. So I'm going to do y equals x squared plus 16x. We are going to add our own number in there. This right here is me completing the square. That's a key part of this. I'm completing the square there. But I still have that 71. I don't want to do anything to the other side, so I'm going to add 71 outside of what I'm completing the square. Now, rather than adding something to both sides, to keep this balanced, let's say I don't want to give Jack money, but I have to give him $5. So I hand $5, and then you just take the $5 right back. And then I didn't give out any money. So in this case, I'm adding something in, but then I'm going to immediately take it away. So I add something, and then I immediately take it away. So whatever I add in, I'm just going to take it away in the next step. And what we're adding there is just that b divided by 2 squared still. So this is going to be 16 divided by 2 squared. I add 16 divided by 2 squared, and then I take away 16 divided by 2 squared. Now I like to box this in because this is the thing I'm doing the completed square on. I kind of think of this as my extra. This is my outside the parentheses. This is my completing the square. So that little section is going to look like something that's I'm completing the square on. Inside here, we got to start with an x. This next number is whatever's inside this parenthesis. So right now, that is our 16 divided by 2. Our 16 divided by 2 is going to go right there. So that is just plus 8. And then we have plus 71 minus 16 divided by 2 squared. 16 divided by 2 is 8. 8 squared is 64. So I'm really doing 71 minus 64, which is going to be a positive 7. Since it's in this form, I can get my vertex. Remember, because it's inside the parenthesis, it's opposite of what you think it should be. So it's actually going to be a negative 8, comma 7. That's my vertex. I also know it opens up because my a value is positive. So I can just find the point negative 8, 7, make it open up, and that's what our graph is going to look like. The next one is probably the hardest completing the square type problem. It has a whole bunch of problems in it. This one has a problem because I have to keep things balanced on the same side. But as long as you remember what I add, I subtract, you're okay. Here we run into the problem, I can't have 3. I can't complete the square with 3 in here. I also can't divide by 3 because I don't want y divided by 3. So instead of doing that, I'm going to factor a 3 out. I'm going to factor a 3 out. But here's where the trouble comes in. I'm going to have 3 times x squared minus 2x. I am only going to factor it out of the thing I'm going to complete the square on. So I'm going to leave that negative 5 on the outside. So when you have something like this, this is the only part we're going to pull a number out of. Just the 3x squared and the 6x, that negative 5 is just going to stay on the outside. And the way I kind of picture that, in vertex form, I need a k outside. This is where that k is happening, where I'm developing this. All right, my next step is to actually complete the square. So we are going to have y equals 3 times Inside the parenthesis, I'm going to have x squared minus 2x plus something. Outside is still that negative 5. If I add something, I'm going to subtract it away. Minus something. Now what goes in that first blank is just our b divided by 2 squared. That's a terrible squared. That's a little better. So I added b divided by 2 squared, so it must mean I'm taking away negative 2 divided by 2 squared. That's wrong. That equation is not balanced. Here it was. I added 8, and then I took away 8. Can someone tell me why this one isn't balanced, even though I added the same number and subtracted the same number? Yeah.
You didn't subtract the same number, it's multiplied.
It is multiplied by 3. If I distribute this 3, I'm actually doing 3 times this. I am doing 3 of these. I am adding 3 of these, and I'm only subtracting 1 away. So since this 3 needs to distribute there when we finish, you need to actually put that 3 out in front there. I have 3 of these, which means I need 3. If I'm adding 3 of them, I need to take away 3 of them. All right, this is now going to become y equals 3 times I completed the square. So we're going to have x minus 1 squared. Just a reminder, we just take what's inside the parentheses, so that's negative 2 divided by 2, and that's negative 1, so the negative 1 goes there. Then we have negative 5 minus 3. Well, negative 2 divided by 2 is negative 1. Negative 1 squared is 1, so I really have minus 5 minus 3, which is going to become negative 8, which is going to be the vertex. 1, negative 8. Remember, it's not negative 1 because it's inside the parenthesis. It is really what makes this 0. So it's 1, negative 8. And since my a value is 3, notice my a value never changes. If my a value starts out as a 3, my a value ends in a 3, even in vertex form. Your a value will always stay the same. All right, continuing on. Any questions on that? That's probably the hardest one for completing the square. If you could do this one, you can do any of the other ones where you have to complete the square. All right, this one we're actually going to come up with a quick graph based upon all that information that we just did. So first of all, we're going to say which direction this opens. Since we have a 2 out front, 2 last time I checked is positive. If our leading term is positive, it opens up. So because there's a 2 out front, don't draw this because it's completely wrong. We know it's going to look something like that. It's going to be something that opens up. Here's something we didn't talk about, but it's always nice with quadratics, is finding your y-intercept. That is that point that goes through our y-axis. And our y-axis is wherever x equals 0. So to find our y-intercept of a quadratic function, you just have to plug 0 in for all your x values. So real quick, and why this is super easy, well, f of 0 is just going to be 2 times 0 squared minus 4 times 0 minus 9. 0 squared is 0. 4 times 0 is 0. Almost all the times, you're just going to be left over with this number here. So your x-intercept is, most of the time, just 0. And whatever your c value is, in this case, is negative 9. Now we can go ahead and plot that. 0, negative 9 is right here. That's 1 point. Now let's go ahead and find our axis of symmetry. our axis of symmetry. The only way you can find your axis of symmetry is if you know negative b over 2a. All right, so we're going to do negative b over 2a. In this case, our b value is at negative 4, so we're going to have negative 4 all over 2 times my a value is 2. Negative 4 is a positive 4. 2 times 2 is 4. Our axis of symmetry is just x equals 1. And I'm going to go ahead and graph that. Let's use a purple dashed line at 1. That line right there is my x equals 1, my axis of symmetry. Somewhere on this axis of symmetry is my vertex. And since this graph opens up, it must be somewhere below here. It must be somewhere around here. Let's go ahead and find it by plugging that 1 into the equation. So to find our vertex, we are going to look for y equals, instead of x's, I'm going to use the 1s. So we'll have 2 times 1 squared minus 4 times 1, and that's going to be minus 9. Just remember, you just take this 1 here and plug it in for your x's. All right, that's going to give me y equals, that's just 2 minus 4 minus 9. Negative 13 plus 2 is negative 11. So our vertex is going to be x value of 1, y value negative 11. So the 1 comes from this x. Your y value comes out when you plug that 1 into your function. So let's plot the point 1, negative 11. This is all the information we need to make a pretty good accurate graph. And that's because this is my axis of symmetry. So what happens on the left side of the graph must happen on the right side of the graph. So you look at this point. I'll draw a little picture. Let's just use light blue. If you look at the other point that we have graphed, that is 1 unit away from our axis of symmetry. Which means if I go to the other side of my axis of symmetry 1 unit, we're also going to have a point right here, which gives us a graph that looks something like this. Now, I'm not sure where it crosses the x-axis. We'll figure that out in a second, but that's our general graph. And a general graph is all I need to come up with my range and domain. Range is what is my lowest y value to what is my highest y value. In this case, my lowest y value is my vertex, which is 1, negative 11. So my y value there is negative 11, and I'm going to use a bracket because it does include negative 11 all the way to infinity. Domain is how far left to right? Well, that's negative infinity to infinity. Remember, I will never take off points if you do something like this, because some people really like to do this where you just go, well, my range starts there. That is my range. It goes up. And you could do the same thing for domain if you get stuck with domain and range. If you're one of those people that kind of make those mistakes. You don't have to do this, but I will not take off points if you write that on there. What time are we over at? 40? Okay. The last thing we need to do is vertex form. And then we need to find our x-intercepts or find our zeros. All right, vertex form. Vertex form, we're going to complete the square on this to find the vertex form. I need to get the equation out. So our equation is y equals 2x squared minus 4x minus 9. So the first thing I'm going to do is I'm going to factor out that 2. So we are going to have something that looks like f of x equals, now we're going to factor out the 2, but we're just going to factor out the x squared and the x portion. So that's going to be minus 2x. And we're going to leave that negative 9 on the outside. So we just factor that 2 out. Now to complete the square, we're going to do 2 times x squared minus 2x. we are going to add something, minus 9, and then since I added something, I'm going to subtract something away. Now what goes in that first blank is b divided by 2 squared. So that's going to be negative 2 divided by 2 squared. The other blank is going to have a negative 2 divided by 2 squared. But we have to remember, since this 2 is outside and would actually get distributed there, we actually have to put that 2 here also. So here I'm actually adding 2 of these, which means I actually have to subtract 2 of them. That's just going to equal 2 times, completing the square is just x. You take whatever's in that parenthesis, which is negative 2 divided by 2, which is negative 1, squared. We have negative 9 minus, well, negative 2 divided by 2 is negative 1. Negative 1 squared is a positive 1, so I have negative 9 minus 2, which is negative 11. So what I have here, I have an a value of 2 and a vertex of 1, negative 11. A value of 2, vertex of 1, negative 11. I did all the work right. The last thing we need to do is find all of our x-intercepts, roots, or zeros. That's the same term for the same thing. I'm looking for our zeros or our solutions to this. So the easy way to do that, if it's already in vertex form, is just do 2x minus 1 squared minus 11 equals 0. That's the easiest way to find our zeros, is plug a 0 in for that y. Now we're just going to add 11 to both sides. We'll have 2 times x minus 1 squared equals 11. Divide both sides by 2. We're going to kind of speed this up. X minus 1 squared equals 11 divided by 2. We need to take the square root of both sides. I'm going to shift this up a little bit. We are just going to have x minus 1 equals the square root of 11 divided by 2. Make sure it's plus or minus. I do need to have not a square root in the denominator, so that means I'm going to multiply the bottom and top by square root of 2. That is just to simplify it. And so we actually have x minus 1 equals plus or minus. Square root of 2 times square root of 11 is square root of 22 over 2. Now we just add 1 to both sides, and our zeros are x equals 1 plus or minus the square root of 22 over 2. All right, we're just going to do one more pretty quick. Since we do have shortened classes, I got to get through it. All right. We have negative 2x squared minus 16x minus 40. It opens down. And it opens down because we have that negative 2. That negative 2 tells me it opens down. To find my y-intercept, I plug 0 in for my x's. So that'd be negative 2, 0 squared minus 16 times 0. That's all zeros, and I'm left with negative 40. So my y-intercept is actually just 0. Negative 40, because if I plug zeros in, I just get out a negative 40. That's a 4, not a 40. There we go. So we have y-intercept at 0, negative 40. I'm going to go ahead and plot that. I'm supposed to find my axis of symmetry. Axis of symmetry is just negative b over 2a. In this case, my b value is negative 16, so it's a negative 16 all over 2 times my a value is negative 2. That's 16 divided by negative 4, which equals negative 4. So my axis of symmetry is that x equals negative 4. I'm going to go ahead and draw that line. Now to get my vertex has an x value of negative 4. So I'm just going to plug that negative 4 into my equation to get my y value out. So my vertex is going to be -4 comma some value. So we're going to have y equals, and we're going to plug that -4 in for our x value. So that's -2 times 4 squared minus 16 times 4 minus 40. Did anyone already get that value out? Yeah. 84? That seems a bit big.
8 squared is 64 minus, oh, I had a -4, that's why.
Oh, okay. Yeah, oh, I forgot to put negatives in. Yeah, it should be -4.
Oh, okay.
Yep.
So then minus 64, which is plus 64, minus 40.
I think it just came out to, I thought it was something small. It comes out to -8. -8. So that would be the point, -4, -8. So we have a vertex at -4, -8, which is maybe about here. And remember, now we have a good graph of this. Because we look at that point, that 0, -40, I just count how many units that is away from my axis of symmetry. That's 1, 2, 3, 4. So I must be able to go 4 in the other direction. 1, 2, 3, 4. And I should have a point right over there. Our range is our lowest point to our highest point. Our lowest point is -infinity. Our highest point is at -4, -8, but our y value is -8, so it's -infinity to -8. Our domain, once again, is -infinity to infinity. Just for the sake of time, I'm going to quickly do our vertex form. And I'm going to do, yes?
Is that a bracket?
Oh, it should be a bracket. Yep, it should be a bracket around -8. I'm just running really low on time, but not enough time to make mistakes. All right. Vertex form. I'm going to jump right to the vertex form because I already know the vertex. I know the vertex is -4, -8. I also know my a value should be a -2. So our vertex form is just going to be -2 x. In order to get a -4 out, I'm going to have a x plus 4 squared minus 8. On your homework, I do want you to complete the square to make sure it's correct, but you can jump right to your vertex form on something like the test if you needed to. Down below it says x intercepts. Does it intercept the x-axis? No, so it's not going to have any real answers. All right, because our x-axis is up here. It has no zeros, no real solutions for those. All right, your homework is to do 4 of these, just like this. I do want you to complete the square to find your vertex form, so you can practice doing that. I also want you to graph each of these on your calculator, because I might just let you use your calculators on this test because we seem very atrocious at using our calculators, so maybe I'll encourage you to learn how to use them. Otherwise, have a wonderful day. No break. You go straight to your 4th period class.
I was always planning on taking the test today, but Mrs. Koenig told me that I had to work on something for later, and I can't take the test with you.
Okay.
So can I take it tomorrow,
Yeah.
second last period?
Mhm.
Thank you. Sorry.
Yep.
Working groups. She checks all of that. She wants one from